When multiplying two radical expressions, and that would just be an expression with some kind of root, square root, cube root, something like that in it. If you have to multiply them and they look like this, these are binomials, and that would be multiplying two binomials. We always use the word FOIL. It just helps us organize our information. So what you want to do is you want to do first times first, and you get 20. Then you want to do the outside ones times each other, and those two only can be multiplied, if you think about it, off to the side here. That's what's really happening, and so therefore we only can put these guys together. The guy under the square root has to stay there. He can't be mixed with the guys that are outside the square root. So we've got 16 square root of 2. Then you do the inside part of the FOIL. That would be 2 square root of 2 times a 5. I'll go ahead and put the 5 in front so you can see it better. And it's positive, so plus 10 square root of 2. Then you do last times last. That's the last one out of each parentheses. And so you have 2 square root of 2 times 4 square root of 2. You can do them out of order since multiplication is commutative. So we could get the 2 times the 4 to give us 8. And then you can also do a radical times a radical and put a new number underneath. 2 times 2 is 4. Well, if you look at that one a little bit farther, the square root of 4 can be broken down to just a plain 2. When you take the square root of 4, you get 2. So you basically just have an 8 times a 2, which we might as well write as 16 right now before we put it back in the problem. So we'll write plus 16 back in the problem. So there's your FOIL steps. And then if you see two like radicals, you can add them together. So 20 plus, then you can basically think of it as you have 16 of these plus 10 of these, so now you have 26 of these. When you're adding, they have to be like radicals to be able to add, but you don't change the radical part. Just like if you had 16x plus 10x, that would just be 26x. When you're adding, you don't change the power on the x. So same thing here, you don't change the radical at all. It'll just stay square root of 2. Then you have the plus 16. Well, we've got two like terms there that could be put together. So 20 plus 16 is 36 plus, and then we'll put the other term back in. And that's as far as we can go because this and this are not like terms, and so we have to keep them separate, and that is our answer. When you're multiplying two binomials that happen to be conjugates of one another, which, by the way, conjugates just means that you've switched out the middle sign and only the middle sign. They're not really opposites of each other because you didn't change the sign of the 5, you only changed the sign in between the two terms. When that happens, it's a very special case, and we oftentimes want to multiply something by its conjugate because of what's about to happen. So let's see what happens when we FOIL this out. First times first, outside 2 times each other, the ones on the farthest outside edges. Then we've got the inside 2 times each other, which we can't mix a radical and a non-radical, we just have to put them side by side. And then finally, last times last, which would be a negative. Now those are both square roots, so you can multiply 2 square roots and get a new square root. Then, if you look at the two terms in the middle, they happen to be like terms, and not only like terms, but they're opposites of one another, which means if you added them together or combined them, they would give you 0, and so they just go away. Then we have 25 left, and we have minus the square root of 49 turns out to be a nice 7. And so now we have two integers that we can just subtract and get 18. Now this will always happen with conjugates. If you multiply them out, you will end up with a real number, and it will be a real number that is rational. And so that can be very useful, and you'll see why on the very next example. Finally, when we divide two rational expressions, oftentimes we can get the bottom, or the denominator, to become a rational number instead of being an irrational binomial. And so oftentimes they'll say the word divide, but really what they mean is rationalize the denominator, because we can't divide any individual terms in this expression. So the most that we could do would be to multiply the bottom by the conjugate, because we noticed on the last example that multiplying by the conjugate happened to give us a rational number, and that's a good thing. That's if they want you to rationalize the denominator, they want a rational number on the bottom, and the only thing that's going to create that is by multiplying it by the conjugate. Now, if you multiply the bottom by the conjugate, you also have to multiply the top by the conjugate of basically by the same number, because if this is not a 1, then you change the value of the whole problem. And you don't want to change the value of the expression, you just want to change the looks of it and the format that it's in, and you hope to get a rational denominator but still have an equivalent fraction when we're done. So multiplying by something over itself is always like multiplying by 1, which doesn't change the value of the original fraction. So that's a good thing. So what's going to happen is you want to put an extra parentheses around the top, the numerator, the original numerator, and then that way you can see that this requires a FOIL across the top and a FOIL across the bottom. Sometimes the top will just have one term and you'll just use distributive property, but this one has 2 times 2, or a binomial times a binomial, so you'll have to use FOIL on top and bottom. So let's see what happens. Here are the steps that the FOIL of the top and the FOIL of the bottom produced. Now let's see if we have any like terms that we can simplify. It looks like if you scan the top, all the terms are different and none of them can be broken down into any simplified radical, and so we have to leave the top exactly like it is. Now on the bottom we have what we hoped would happen. We have two things that are canceling each other out and making a 0, and then we also have a 4 minus, well, this is a nice square root that gives you 3, and so across the bottom we're going to get just a 1. Well, putting a 1 on the bottom of something isn't even necessary, because dividing by 1 will just give you the numerator, and so rather than writing the numerator over 1, we can just drop the denominator altogether and just write the numerator as the final answer. Now the bottom, sometimes the denominator will be something other than 1, and then you'd have to leave it there. But since it is a 1 on the bottom, dividing by 1 just gives you back the same thing that's on the top. So our final answer on this particular one is this long expression.